let's study the chapter logarithm. So, first, what is meant by logarithm? Let's go through the definition of logarithm, then let's see its properties and all that, right? So, see, the logarithm of a given number to a given base is the index of the power to which the base must be raised in order to equal to the given number, right? It's confusing definition, right? Let's decode that. Right. So, first let's see how logarithm is represented. Then let's see the definition which you can understand easily. Right. So, it is represented by log, right? So, it is given a number, right? So, that number is written here, and it is also given base, right? Base always will be down. So, at this we will be writing base, right? So, what is this? What is they said is the logarithm of a given number to the given base is the index of the power to which the base must be raised in order to equal to the given number, right? What is meant by that? What is the power by how much a should be raised, that is base should be raised such that it is equals to n. Means what? Suppose let a power is increased to some x, let's take that x, then it should be equals to n, right? This is what it is saying, right? So, what is the power of a that it should be raised such that it should be equals to n, right? So, that number let it be x. So, a power x is equals to n, right? So, what we said log value is this index power, right? So, therefore, log n to the base a is equals to x, right? Right? So, what is this called as? Base. This called as number, and this is called as, right, index. So we can see that this and this are both are equal. So, both are equal, but we have used here logarithmic function and we have used here exponent function. So, that's why this is called as logarithmic expression. Whereas, this is called as exponential form. Right? So, you got the definition. Then, why we should study logarithms? Like, if there is no use, why we should study, right? So, let's see what are the use of logarithms. So, these logarithms are used to solve exponential equations. Like, we have seen that logarithms or exponents are interchangeable, right? So, if we have exponential equations in large numbers or difficult equations, then we will be using logarithms, right? And also, if we have many high numbers like around 3 power 40, 2 power 20, with these large numbers we have equations. So, how we should solve that? Then also we will be using logarithms. And also, we will be using logarithms in different fields, such as we have heard about trigonometry, algebra, and all that. In that also, we will be using logarithms, which we will be studying in the further chapters, right? So, now we have gone through the definition and also why we should study logarithms. Now, let's see what are the properties of logarithms, right? See. And before that, let's go through some examples so that you can understand the definition properly of logarithms. So, we have seen, you have known the definition. So, let's see. For example, log 81 to the base 3, right? So, what should be the power of 3 such that it is equals to the 81? Right. 3 power 1, 3, 3 square, 9, 3 cube, 27. Right, 3 power 4 is 81. So the answer is 4. Right. With this, we can say that directly through definition, answer is 4. Let's see some process method through exponents. Right, exponential method. This is through definition, right? So we have assumed that what? Log 81 to the base b, let it be x, right? So how we should convert this into exponents form? Right, 81 is equals to 3 power x. What is 81 in the power of 3? Right, 3 power 4. 3 power 4 is equals to 3 power x. Through exponents law, what is exponents law? If a power n is equals to a power n, then n is equals to n. Right. So we can say that b base is same. So x is equals to 4 through exponential method. Right. Like this, let's see another example also. So log 8 to the base root 2. Right. So in this, we can directly know that 3 power 4 is 81. We can directly solve the definition. But what about this? Root 2 power. What should be the root 2? Power of root 2 such that it should be equals to, right? I can't calculate that much easily. So let's go through exponent method. Right? So let it be x. So 8 is equals to root 2 of x. Right? So this 8 in terms of 2. What is the power of 2? That should be equals to 8? 3. So 2 cube is equals to root 2. What is meant by root 2? Right, 2 power 1 by 2. 2 power 1 by 2 power x. Right? See, again the power base is same. So same with this formula. 3 is equals to x by 2. Right? So x is equals to 6. So root 2 should be, the power of root 2 should be raised to the 6 such that it is equals to 8. Right? But we can't calculate through directly like 3 power 4 is equals to 81. So that's why we are using exponent form. Right? Okay. Now let's go to another example. Right. So let's go to another example. So let's take log 7 to the base 7. So what is the answer? Right. See, what is the power of 7? Should be raised such that it is equals to 7. Right. 7 power 1. So the answer is 1. So through this we can derive a property. What is that? Log n to the base n is equals to 1. Right. So this is a property. Right? See, even if we take log 10 to the base 10, what it will be there? 1. So anytime log n to the base 10 is equals to 1. Right? So let's write the property at a side so that we can remember it. Properties. Log n to the base n is equals to 1. Right? So next. Now let's go through another example, that is log 13 to the base 1 by 13. What should be the answer? Right? Let's see through exponent method, that is dx. Right? So 13 is equals to 1 by 13 power of x. Right? So 13 is equals to 13 power minus 1 of x. So again exponents formula. So 1 is equals to minus x. So x is equals to minus 1. So we to the base 1 by n is equals to minus 1. Right. So we got another formula, that is log n to the base 1 by n, that is equals to minus 1. Right. Okay. Now let's go through another example such that we can derive one more property. So let's take an example, log 1 to the base 72. Right? So what is this value? Shall I take it as x? Right? So 1 is equals to 72 power x. What should be the power of 72 such that it is equals to 1? Right? X should be 0. So x is equals to 0. Right? So always log 1 to the base n is 0. So we got another property, log 1 to the base n is 0. Right? So log 1 to the base n is equals to 0. Right? So before going to further properties, let's see the conditions of logarithm where the log n will be existing and where log won't be existing. Right? So let's see some characteristics of log first. Then we will go to the further properties. Right? So see. So we have studied that log n to the base a is equals to x. Right? So in this, always n and a should be always greater than 0. Right? N and a should be always greater than 0 and base should never be equals to 1. A should never be equals to 1. Why it is not equals to 1? See. So let's take an example, log 72 to the base 1. Right? So this is equals to some x. Right? 72 is equals to 1 power x. In 1 to the power of anything is 1. Right? So how can it be x 72? It's not possible. Right? So it is impossible. So what we can take out from that? Base should never be equals to 1. So that's why a should be greater than 0 but not equals to 1. Right? Okay. Some people will be getting that doubt. Like I will replace this with 72 with 1 so that I can get 1. Right? No, actually. See, let's take 1 log 1 plus this one. Right? So it should be taken as x. Right? So 1 is equals to x power 1. Sorry, 1 power x. 1 power x. Right? So what should be the value of x such that this equation should be equal? It can be 2, 3, 4, 5, 6, 7. Infinity numbers are there. When minus 1, minus 2, infinity numbers are there. So, but we need to get a single value. Right? So log to the base 1 in any case is not possible. So a should never be equals to 1 and a and a should be always greater than 0. Right? And logarithm value should be always distinct. Means if n and a are fixed, then a should be always fixed value. It should never change. Right? So log has unique value. Right? So we have done with some basic properties and some conditions where logarithm will be there or will not be there. The conditions which we should satisfy before performing logarithmic function. And then now let's go to further properties. Right? So let's go to further properties. So let's take m comma n greater than 0 and a is also greater than 0 and a not equals to 1. Right? So let's write some properties. Right? So log mn to the base a Right? So product of two numbers to the base a, that is equals to log m to the base a plus log n to the base a. Right? So this also we can add in the property this. Right? See, log mn to the base a is equals to log m to the base a plus log n to the base a. Right? Let's take an example such that you can understand this property clearly. So let's take log 5x to the base a. Right? So this is m, this is n. So log m, that is 5 to the base a plus log x to the base a. Right? Got it? So now let's go to next formula, next property. What is the next? Log m by n, that is equals to the base e, right? We should never forget base. That is equals to log m to the base a minus log n to the base a. Right? If it is multiplication m into n, then we have plus. If it is m by n, then minus. Right? So let's write this as. So let's take an example. So I have log 5z by y to the base 20. Let's take base 20, right? So how we can split it through these both properties? So first a by m and m by n. So m minus n. So log 5z to the base 20 minus log y to the base 20, right? And then see this n into n, right? So log 5 to the base 20 plus log z to the base 20 minus log y to the base 20, right? So we have used this in this n by n formula and also n into n formula, right? So these properties are used in the further problems where you can understand better, right? Now let's go to next property, that is log n to the base n to the base a, right? So in this n will be coming to the front, right? n into log n to the base a. Right? So let's take an example. Log x power 5 to the base a. Right? So that will be 5 log x to the base a. Right? You got it? So yeah, we need to add the before formula. Right? Log n by n to the base a is equals to, right, log m to the base a minus log n to the base a. Right? Next we should add this formula also. Log n power n to the base a is equals to n log n to the base a. Right? Now let's move to the next. So a power log n to the base a. What is this value? This much. A and to the power of an active logarithm, right? So if this base and this base are equal, then only this value will be coming out, that is the value n. So if this base and logarithmic base both are same, then only the number value will be coming out directly. So let's add values here. A power log n to the base a. If these both are equal, then this will be coming out, that is n. Right? So let's take an example. log 72xy to the base 5. So what can it be? That is equals to this base, both are equal. So this will be coming up. So 72xy. That's it. It's completed. Right? So let's move to the next property. The next property is log m a to the base a to the power of t. That is equals to 1 by t log m to the base a, where t should not be equals to 0, right? If t is equals to 0, then next one logarithm which base 1 is not possible, right? So see, so what is this? So see the difference first. If we have the power at base, at number position, then it is coming directly out. Where is it? Yeah, this one. See, it is directly coming out. But if it is in the base, it is coming to the reciprocal of that. So if it is in the base, then it is coming to reciprocal. See the difference. You should not confuse between these both formulas, right? So if it is in the number, then it will be directly coming out. But if it is in the base, then the reciprocal is used, right? So let's see. Log m to the base a power t, that is equals to 1 by t log m a, where t not equals to 0, right? So let's take an example. Log 8 to the base 2 square, right? So what shall we do? 2 will be coming out, right? So what? How it will be coming? Not 2, 1 by 2, right? 1 by 2 log 8 to the base 2, right? So what should I do? Now 8 can be transferred in terms of 2. Yes, it is 2 cube. So log 2 cube to the base 2. So what is this formula? M power n will be coming out. So t will be coming out. So 1 by 2 into t into log 2 to the base 2. Right? It is in the form of what? Right. Log n to the base n, which is equals to 1. So 1 by 2 into 3, that is equals to 3 by 2. Right? Okay. Now let's move to the one important property, that is C. So log m to the base a. Right? So this we can write it as log m to the base b by log a to the base b, where b not b greater than 0 and b not equals to 1. Right? It is in base. Okay. So see this. Here we are changing the base. So this is called as base changing property. This is very much important property. So you should never forget this property. So see this. We have log m to the base a and log m to the base b by log a to the base b. Right? So remember this. For this, let's take an example. Log 4 to the base 3 into log 3 to the base 7. So how we should calculate this? Let's see. So log m to the base 8. So let's take it to the base 10. I mean b should be taken as 10. So log 4 to the base 10 by log 3 to the base 10 into log 3 to the base 10 by log 7 to the base 10. Log 3 to the base 10, log 3 to the base 10 is cancelled. So what is remaining? Log 4 to the base 10 by log 7 to the base 10, which represents this form, right? Log m to the base b by log a to the base b, that is equals to log m Now let's go to the next property, that is log m to the base a is equals to 1 by log a to the base m. M should not be equal to 1. Right? Oh, first next add this property log m to the base a is equals to log m to the base b by log a to the base b, where b not equals to 1 and b greater than 0. Right? Okay. See, there is not much change with this. So, see this. In this, I am replacing b as a. Sorry, I will replace b as m only. So, let's see. So, log m to the base a is equals to, what is this? Log m. In place of b, I am writing m by a to the base b, which means m. So, log m to the base of 1. So, 1 by log a to the base m. Right? You got this. Okay? So, now you have understood. Now, let's add this into the property list. So, log m to the base a is equals to 1 by log a to the base m. Now let's move to the next property. Now let's move to the next property. So log, okay, not log, m log n to the base a. Right? So in this we can replace the m and n. But we should not touch the base, right? Okay. So we can write it as n log m to the base a. We can replace this, but we should not change the base value. Okay. So let's take an example so that you can understand better how we should use, why we should use. So I have 7 log 25 to the base 49, right? So what shall I do with this? See this. 7 power 49, 25, 49. See, this is 7 square, this is 7. So, if I shift this 7 to here, so it will be somewhat simplified, right? So, I will shift this. So, how with this formula? So, this is m and a. So, m and n are replaced. So, 25. Log power of log 7 to the base 49, right? So 25 log 7, 49 is right, 7 square. So with this formula, what is this formula? A power t, right? So 1 by t will be coming outward. So 25 1 by 2 power of log 7 to the base 7. So log 7 to the base 7 value, right, it is 1. So 25 power 1 by 2, which means root of 25, that is right, 5. So in this case, we will be using this formula, this property. So let's add this to the property list. So m log n to the base b is equals to m log m to the base c. Right? This and so hence we completed with properties.